So for this problem, we have a collar that's on a rod, and they say it's a smooth collar. And we're supposed to find and it's attached to the spring that's attached to the pin, and they want us to find the initial acceleration and tell us that it's a 10 kilogram collar, and then also the spring has an unstretched length of 1 meter. And they tell us that K equals 10 newtons per meter, and then they tell us some about the dimensions of it. So for this one, we're just going to do the same, where we start with the free body diagram is equal to the kinetic diagram to draw this out. So we have our collar on both sides, just drawing the shape of it. And then we have G, and then we just need to draw the forces on the left side. So on the left side, we have that force of the spring. We're going to have a normal force. And then we're also going to have the weight. And we know that direction of the spring, it's a 3, 4, 5 triangle. So 3, 4, 5. And then we also... we're going to set this equal to the kinetic diagram, and then for the kinetic diagram, we're going to have m times a sub x. We don't have any acceleration in the y direction because it's on that collar, or in the z direction we don't have any rotation or anything on it. So we can, and we're looking for that initial acceleration, so we're looking for that a sub x. So we can sum the forces in the x direction equals max, actually equals negative max, because it's pointing to the left. If we're doing the right, it's positive. And then we have that we need that x component of the spring force, which would be also to the left, so negative F sub s times that 4 over 5 equals negative, and the mass was 10 kilograms, so 10 kilograms times a sub x. The force of the spring we know is so negative, so it'd be K times L minus L naught times 4/5. It's going to equal negative 10 kilograms times a sub x. So we get, they give us the K is 10 newtons per meter, so negative 10 newtons per meter. The L is the stretched length, so that would be 5 meters because it's 3 meters up, 4 meters over, so that'd be 5 meters would be L. And minus that unstretched length, which would be 1 meter. And then that's times 4/5 equals negative 10 kilograms times a sub x. Then we just need to do some multiplication. And we end up getting acceleration in the x direction equals, let's see, this meter cancels out with those. So we get newtons divided by kilograms are the units. And we get 3.2 newtons per kilogram. And if we just do that quick unit analysis, we get 3.2, it's kilograms times meters per second squared divided by kilograms. So the kilograms cancel out, so we get meters per second squared. So we get a sub x equals 3.2 meters per second squared. So 3.2 meters per second squared for the a sub x.